All right, welcome to part two of psychedelics of 4 parts. I've turned off the video as it was creating files that were obscenely large, so I'm going to try to simplify things by just giving you the audio annotation. All right, so moving on to day two. So I talked before was how we categorize psychedelics by their chemical similarity to endogenous neurotransmitters and receptors like the serotonergic receptors and transmitters, glutamatergic, and etc. But you can also categorize psychedelics by how they impact perception. And I'm going to talk about two general ways we do that. The two general classifications, and they are somewhat fluid, are classifying things as either a true, like classic psychedelic, and or a dissociative drug or dissociative psychedelic. So just call it the psychedelic case is that you are truly imagining something that is not there. Your perceptions are altered. You It distorts your incoming thinking. Your sense of ego may be altered or dissolved. There may be other kind of dissociative effects, but those effects are somewhat dwarfed by the change in how you perceive the world. You, again, are potentially seeing things that just aren't there. You actually see that elephant in the room, even though there is no elephant in the room. Where drugs that are more dissociative and don't have a lot of the hallucinogenic properties are drugs that make you feel kind of out of your body, just generally that you're not yourself, you're just disconnected from your own body and form. And so those types of drugs are called dissociative drugs. And there's some overlap. You can have a dissociative drug if you take enough of it, you're still going to have some psychedelic components, but these general categories are useful. So some examples. So the classic psychedelic drugs are those like LSD, DMT, which is a component of ayahuasca, psilocybin, salvinorin A, mescaline. These are the classic psychedelics, and that they have those types of true hallucinatory experiences. Then you have the ones that make you feel apart from yourself and apart from your body. Those are ketamine, PCP, DXM, nitrous oxide, and ibogaine. And interestingly, a lot of those drugs are actually trying to be used recently to fight addiction. We'll see what happens, but ibogaine and ketamine, I know, are used to look at addiction. Ketamine is being used to look at its ability to treat um, depression as well. So are LSD and psilocybin and things. Okay, moving on. All right. These two categories, as you might imagine, really don't do justice to all of the deep psychological effects or impacts of taking a psychoactive drug, especially something as powerful, let's say, as LSD or psilocybin. And so, to get at more of the nuances of the mental states that these drugs create, a different scale was developed called the Dietrich Altered States of Consciousness Rating Scale. And it's a scale that's used by essentially giving a survey to somebody who's taken a psychoactive drug. And then they have to fill out the survey and check certain boxes. And then in the end, the results are aggregated into an 11-point scale called the ASC scale. And this scale then can be put on a pretty plot like these that shows you the constellation of symptoms or effects and that person had, the subjective effects that person had by taking that drug. And these effects have all these interesting names, but they really do summarize some of the experiences, like elementary visual alterations. I mean, they can actually point and circle that stuff. Elementary visual alterations. Um, Synesthesia, when you combine senses. Synesthesia means you're mixing things up, like you're tasting a sound, you're seeing um, a sound. um, you kind of shapes are associated with numbers and things like that. There are all these interesting synesthetic components that can happen with certain psychoactive drugs, especially psychedelic drugs. Vivid imagery is a very, of course, probably one of the more common effects. changed meaning of percepts, like the meaning of what you saw is no longer there. The intention, the function of an object is no longer the same. That's in the blue category here. But then you have other categories that have this disembodiment. You're no longer a part of your body here in the purple category. Impaired cognition and control, anxiety, the sympathomimetic situation. Then you have these more emotional components in the brown area here, where you might get senses of insightfulness, religious experience. These are the kind of the entheogenic components of psychedelics. The experience of unity, maybe of God of some sort, and this blissful state. So these are all other components of psychedelics. And what you see here is the weighting of the subjects who taken, in this case, psilocybin at different dosages, of the components essentially on this plot. So the further out you are on the plot, the stronger the component. So this group of subjects under psilocybin had very strong elementary visual alterations, strong vivid imagery, and such, and strong synesthesia. So that was under psilocybin, which is the psychedelic. Then you have a dissociative like ketamine here, and you get a different constellation where they have much more, like we were talking about, disembodiment. You're kind of feeling dissociated. You're dissociating from your body or from your ego. And as you might expect, when you dissociate from your ego and who you are, you might have some anxiety, although apparently ketamine has pretty low anxiety, which is interesting. PCP, you get a high anxiety. Ketamine has low anxiety. But it does impair control and cognition. There is some of the elementary visual alternations, so it's somewhat psychedelic. You do get a little bit of this synesthesia, perhaps, at these higher doses. Vivid imagery. You get the changed meaning of perceptions there, and you get this. Some people do get this experience of unity. So it's interesting that you get these entheogenic components, for example, with ketamine, but you only really get one of them, this experience of unity, strongly. So you can see where just having two categories of either psychedelic or dissociative might not be enough to capture the constellation of feelings and images that you get with different drugs. Okay, diving into this a little more deeply, this particular scale, they even subdivided or categorized this general scale into these different colors. And those colors indicate three functional groupings, where you have this, what the Dietrich scale, maybe Mr. and Mrs. Dietrich came up with, oceanic boundlessness, which is this kind of sense of becoming one with the world. That's what all the orange ones are supposed to be a component of. The purple ones are more in this ego disintegration component, this disembodiment component. And then the blue is more on this visual, classic psychedelic hallucination type of component. And you can see where the psychedelics are higher up in the blue category, the visual, what we'll call restructuralization, where you have the vivid, florid, visual, hallucinatory effects. Whereas the dissociatives are higher in the purple group. They're higher in the disembodiment, ego disintegration, and the loss of control. So it's a good scale, and it's a nice scale in that it really helps summarize the many different effects people might feel under psychedelics, and how different drugs really can have a very different arrangement of effects. And even on the same person, a different dosage or a different situation or a different context can induce a different set of experiences. Okay, with the tail of the bobcat, we'll now switch gears and go into the neurotransmitters involved in the psychedelic effects of these drugs. So, for most classic psychedelics and MDMA, which is in your classic psychedelics, that's ecstasy, they appear to act on the serotonin system, and specifically on three receptors, the 5-HT1A, 2A, and 2C receptors. Now, the one that's most commonly associated and has been studied the most with regard to psychedelic experiences is the 5-HT2A receptor. And so you'll see that coming up again and again, but it's important to note that these drugs act on many different serotonin receptors, and they all might play some role in the psychedelic effect. But the one that's been studied the most, the one you'll hear about the most, is the 5-HT2A, but don't discount the 2C and 1A receptors. All right, so in the dissociative psychedelics, as I mentioned before, like ketamine and PCP, glutamate and NMDA receptors are the big players. Now, what I've shown below, this picture here of this smiling guy here with the big molecule, that's Albert Hoffman, who worked at Sandoz Laboratories. And he is the discoverer and inventor, effectively. He made a new compound, LSD. And so Albert Hoffman's drug here, LSD, as you can see, shares a lot in common with the shape of serotonin. And so you can see how this particular drug might bind very well with the receptors that have been tailored to bind to serotonin. And so many of the drugs that are psychedelic share something like this shape, so that it can bind well with the serotonin receptors. Now, the other drugs that are dissociative, they act more on the glutamatergic system. They don't necessarily look like glutamate per se, but they can bind and actually block NMDA receptors. All right, I'm going to go over a little bit of history. It's always good to have some history to put things in perspective. And so here we go. This is actually, I got some of this from this really nice article in Nature Reviews Neuroscience. I'd highly recommend it. It gives you a bigger picture on the development of psychedelic drugs over time, at least since the 1800s. All right, so you don't need to memorize all the details, but I just like it because it puts things into perspective. All right, so one of the first important discoveries was the ability to take mescaline from peyote and isolate it from the peyote cactus. And that was done in 1897 by this guy here, Arthur Hefter. And so he figured that out. And this has been a general thing. It's like you'll have some chemist and he or she will figure out what the core active component is in a particular drug. All right. Then they were not only do you have to discover it, but you have to be able to synthesize it. And so a little later, then it was synthesized. Then all the way back in 1926, the psychoactive psychedelic drug PCP was developed, completely artificial drug. And that was developed initially as an anesthetic, and not a great one because it makes people a little nutso, but it does work if in certain high doses. All right. Then way back in 1938, Albert Hoffman, who I mentioned before, synthesized LSD from a fungus. We'll talk about that in a bit. So he figured out the active component and added some extra stuff to it and made LSD in 1938, but thought it was kind of a worthless compound and put it on a shelf, and then didn't really think it had an effect until 1943 when he accidentally put it on his own skin. All right. Now then back in 47, you used to have the first actual scientific study of what LSD does to people. And so people actually started the first scientific investigation of the psychological, emotional, therapeutic effects of LSD in 47. And then it was actually used later on to target depression already back in 52. And that's 1952. And that's interesting because it's taken us more than 50 years to get back to this. Because psychedelics, well, in the 70s, were essentially outlawed. And so we haven't really returned to this investigation of depression for quite a while. But the first study went way back. Not necessarily the best studies in the world. They weren't very well controlled, but they were a start, and they occurred way back in the 50s. All right, the first clinical use of LSD was even happening around that same time in 53. And then you have good old Albert Hoffman, who's just the real gung-ho about figuring out active components in psychedelics. He found that he could synthesize psilocin and psilocybin. Psilocin's the active psychedelic-inducing component in the mushroom, So we figured that out. Ketamine was invented way back in '62, and it replaced PCP as an anesthetic. It doesn't make people as terrifying and nutso as PCP. And then later on, LSD makes a resurgence with a lot of promotion from people like Timothy Leary and appears on the streets. So it definitely helped bring in the drug kind of addled 60s. So LSD hits the streets. And then definitionally, the term dissociative anesthetic for drugs like ketamine and PCP was invented back in '65. Okay, just to take it aside, I mentioned that mescaline and the active component of peyote was invented way back in 1897 or so. But peyote, just to tell you, that's something that we are pretty close to up here, and that this is grows indigenously in the Southwest, mostly New Mexico and northern Mexico. And so it's native out here. Definitely used a lot. It's very entheogenic, and that's been used for thousands of years for healing rituals by the native populations in North America. And it definitely produces hallucinations and a lot of sickness temporarily, of course, can make you throw up a lot. But it's very effective at inducing these psychedelic experiences, just to show you. It's just this little cactus. If you cut it, I think a little sap oozes out. I think that can be a component of the psychoactive. That's where the psychoactive stuff is. All right, going back to the timeline. Okay, '60s happens and people aren't very happy about it. A lot of bad things happen with regard to psychedelic drugs, mostly a social reaction. And in response, Sandoz, trying to avoid causing more chaos and liability, they stopped supplying the market with LSD. Um, then they're also a little later than that in '70. That's when Richard Nixon actually puts everything on Schedule 1, which pretty much prevents any scientific investigation of these drugs. Um, and then later on, some of the mechanisms of some of the psychedelics, in this case, in this dissociatives like PCP, are starting to be figured out. It took 1983 for them to figure out that it acts on the NMDA receptors, which is cool. And then similarly, they found later on that some of these traditional serotonergic agonists, drugs like LSD and psilocybin are acting on this 5-HT2A receptor. So we're finally getting at the brain receptor mechanism of these drugs back in the '80s. And then more studies on the brain effects, in this case, neuroimaging, fMRI studies in psilocybin start in the '90s, and they're getting more and more today. And then ketamine is taken off a Schedule 1 like level and it's put on a Schedule 3, so it's much more easy to use in both research and as anesthesia. It's actually used quite a bit in veterinarians' offices as an anesthetic. So ketamine is now much more widely used, and that's in 1999. Okay, I'll end there on part 2.